All right, we're back. What you guys see right here, I'm going to call some bins or some boxes. And each of these boxes have intervals on them. So it looks kind of like what we did on the sideboard last week. Right? We have to know how to say these things. This says between 4 and 8, including 4. This says less than 4. This says anything greater than or equal to 8. So now what you guys did on that sideboard, everyone got assigned a number and then decided what interval it should go in. I'm going to do the same thing here, but I'm going to decide what little box, what little bin this should go in. -2. -2 is not greater than 8. It's not between 4 and 8. Is it less than 4? Yes, it is. So 2 would go in this interval. -2 would go in this interval or this bin. Let's try another one. How about 8? Where should 8 go? I can't tell, my 8s are gross looking. Take a look, see what you think. Bam. Greater than or equal to 8. Well, this is 8. That's equal to 8, so it goes in the blue box, the blue bin. How about another one? 1. Where does 1 go? Less than 4. It's definitely less than 4. It goes in the pink bin as well. So we have these little intervals where numbers fit in. We're going to do the exact same thing that you guys just did a second ago with evaluating functions. But now it's going to be all of them mushed together into one. This is called a piecewise function. Okay, a piecewise function, f of x, is defined as, we use a little brace, this is called a brace. We want to use this equation, 2x plus 1, when x is less than 4, when we're on this interval. If the number I give you is less than 4, plug it into this one. Next one, 3 minus x, when x is between 4 and 8, including 4. So if I give you a number that's between 4 and 8, including 4, falls in this interval, we plug it into this equation. And then finally the last one, just whatever x is, if your x value is greater than or equal to 8. If I give you a big old number, bigger than 8, then you're going to plug that into this equation. Okay, let's try one out. If I asked you to evaluate f of 1, okay, the first thing we have to decide, remember, f of 1 means plug in 1, but we run into an issue here. Where do I plug it in? I have 3 different equations. On a piecewise function, it's made up of pieces. Which one should I use? Okay, well, we look at the intervals. The intervals will tell us which one. Where does it belong? What bin does it go in? What equation should I use? So 1. Is 1 greater than 8? No. Is 1 between 4 and 8? No. Is 1 less than 4? Yes. Ding, 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 ding. It's telling me to use the pink equation and do exactly what you guys just did a second ago. So I'm going to go to the pink equation. I'm going to take the x out. I'm going to put a 1 in its place. And then we evaluate. 2 times 1, 2. 2 plus 1, 3. And we're dancing. F of 1 equals 3. Okay, let's try another one. Let's try f of 6. It says to go in there and plug in a 6. But where? I got 3 choices. Okay, is 6 less than 4? No. Is 6 between 4 and 8? Yes. So here's my equation. Ding, ding, ding. I should go into this equation and plug in a 6. So I go in there. I take my x out. I put parentheses in its place. In those parentheses goes a 6. 3 minus 6, -3. And we're dancing. Still dancing. Good. A lot of dancing here. Okay. Very last one. Let's try it. What if I asked you to evaluate f of 8? F of 8, okay? I got 3 choices. I need to plug in an 8. Do I do it here? Do I do it here? Or do I do it here? The intervals will tell me. Is it less than 4? No. Is it between 4 and 8? Well, it's exactly 8. But this isn't or equal to, so it's not this one. Finally, this one. X is greater than or equal to 8. Or equal to. If I'm plugging in an 8, ding, 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 I'm using the blue equation here. So I'm taking the x out. That's kind of weird. I'm going to take the x out, put parentheses in its place. In those parentheses goes what I'm plugging in. It happens to be an 8 this time. So I plug in an 8. The answer is just 8. Weird one, but true. Okay, we're dealing with piecewise functions. The intervals tell us which one to use, and then we're just plugging them in just like you did before. Let's try these examples and see how you guys do. Here's our next example. K of x. K of x is made of 2 different pieces. First piece is -4x plus 5. It's linear, as long as x is less than 7. The next piece, 2 minus 3x, linear, when x is greater than or equal to 7. 2 pieces on these intervals. I want you to evaluate k of 0, and then I want you to evaluate k of 8. Take a minute, hit pause if you need to, and then come back and let's see if you got them right. Okay, hopefully you hit pause and now we're back. K of 0, giggling at my own jokes. I need to plug in a 0 in for my x. Take my x out, plug in a 0, but where? Okay, that's what this is going to tell me. When x is less than 7, use this one. When x is greater than or equal to 7, use this one. 0 is definitely less than 7, so it's telling me to use this equation. I'm going to go up into that equation. I'm going to take the x out, and I'm going to put a parentheses in its place. I'm plugging in a 0, and then I'm evaluating. Negative 4 times 0, 0, 0 plus 5. It equals 5. Easy stuff. Next one, k of 8. Greater than or equal to 7, use this one. This is definitely greater than 7, so I'm going to use this equation, this piece of my function. 2 minus 3, set of parentheses. In those parentheses goes whatever I'm plugging in. 8. 3 times 8, 24. 2 minus 24 equals negative 22. And we're dancing. We're evaluating piecewise functions from an equation. You've done it with a graph. The graphs have already done all this algebra and all this for us. We just have to go read off the graph. If I went over to 8 on my graph, I would have to count down 22 units to get to my graph. If I went to my origin, went to the 0 where x is 0, I would have to go up 5 to get to my graph. These are connected. Equations, tables, graphs, they all say the same amount of information, same information, just in a different language. Okay? Try this next little quiz and then we're moving on.